In this example of design exploration using motion, we will attempt to catapult a ball into a box. For mechanism packaging purposes, the main objective will be to minimize the angle of the arm. To achieve this, we will start by creating a variable which controls the angle of the stop block. We will then create two responses, one for the angle of the arm and the other for the contact force between the ball and the inside bottom of the box. Finally, we will create a constraint which monitors the force between the ball and inside bottom of the box. If the force is greater than 1 Newton, the run is considered a successful run. To begin, we'll run a regular motion analysis to be sure the model is working as expected. At this point, we do not know what angle is necessary for the optimum throw. Next, we'll assign a variable which controls the angle of the stop block. This is done by editing the fully defined sketch and assigning a variable to the angle dimension. In this case, we will name the variable stop block angle. Once variabilized, the variable manager can be used to make design adjustments quickly and easily. Next, we'll change over to the Design Exploration tab to set up the optimization. Here we'll choose the variable to include in the optimization. Next, we will define the upper and lower bounds of our variable. The slider can be used to preview the extents of each bound. Next, we will define two response outputs. The first response will be for the angle of the arm. We choose the arm, we provide a name for the response, and we choose the component we wish to create the response for. The second response is for the contact force between the ball and the inside bottom of the box. We provide a name for the response, and we choose the component we wish to monitor. Next, we will define an objective. At least one objective is required for an optimization. Our objective will be to minimize the deployment angle of the arm. Finally, we will define a constraint requiring the contact force between the ball and inside bottom of the box to be greater than 1 Newton. Anything equal to or greater than 1 Newton tells us that the ball has made it into the box. Next, we will run the optimization. You may continue working in Inspire while the optimization is running. Once the optimization is complete, we can review the results using the DE Results Explorer tool. This helps give insight into the different design variations, whether it be the optimal run or a run that did not meet the constraint criteria. The result from any run can be loaded and animated. In addition to viewing the animations, we can also plot the results using standard functionality of the Plot Manager. In this example, there were other feasible runs where the ball made it into the box. However, run 42 had the smallest angle, which was the objective. If desired, you can permanently apply the variables to the model, creating a new baseline model. This concludes the example.